Hello there, I'm Thomas. This is the British American pilot flying the Boeing 777-300ER into night flights from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany, and then coming back to the Zurich International Airport runway 14 for a Lszh localizer. Lighting right now I'm in the cockpit for the pre-takeoff preparation of the PMDG simulation and Microsoft Flight Simulator X Boeing 777-300ERX. I'm going to start showing you the cockpit instruments, the displays, and the functions of the Boeing 777-300ER jet aircraft. I'm going to start with the primary flight display. That displays the airspeed indicated, the airspeed selected from the autopilot and flight director system panel, the FPS, the ground speed, the radio altitude above the ground level, the magnetic heading and track, the magnetic north pole and true north pole, and the magnetic variation depending on where we are in the world. We have the barometric altitude above the sea level, the barometric pressure of the outside atmosphere, the target altitude selected from the autopilot and flight director system panel. Also we have the vertical rate of climb descent of the aircraft in tens, hundreds, and thousands of feet per minute. That determines the trigonometric angle and decrease the steepness of the trigonometric angle and decrease the angle the aircraft climbs or descends. We have also the radio altitude above the ground level. We have the altitude indicator of the pitch ladder in degrees and the bank angle in degrees. the ILS localizer, the horizontal localizer and the vertical glide slope, the crossbar source of the flight director crossbars for manual guidance of the aircraft, and the autopilot crossbars for automatic guidance of the aircraft. We have also you can see the angle of attack of the aircraft as it flies. Also the flight mode annunciator with the autopilot and the autothrottle. Later on in vertical navigation mode. We have also the magnetic heading and track magnetic north pole and true north pole magnetic variation depending on where we are in the world. You can see also in the navigation display that displays the GPS position. You can see also the terrain and weather reflections, the magnetic heading and track again, magnetic north pole, true north pole, magnetic variation. We have also the you can see other aircraft flying around our own aircraft. You can see the distance they are located, the altitude difference with the our own aircraft. You can see their direction and the rest speed, and this is this is created using the transporter, the ADS-B and ADS-C transmitter receiver. The transmits and receives our own frequencies and sends to other aircraft or the air traffic controls, and also receives from other aircraft, and it generates all these calculations about the air traffic using the TAKEOFF system, the traffic original alert system that displays the diamond shaped other aircraft in the navigation display over here. So you can see the primary flight display, the navigation display, primary flight display with the flight mode annunciator, navigation display, the autopilot and flight director system panel, the upper and the lower ACAS sends indication controller system display, the thrust levers. So I'll show you all the systems. So in the navigation display you can see also the wind direction and speed. You get to the next waypoint within the overflying. We're gonna use the flight management computer, the control display unit of the flight management computer, to input all the data of the aircraft for takeoff, like the takeoff weight that includes the empty weight plus the passenger plus the cargo plus the trip fuel plus the reserve fuel plus the taxi fuel, and this will include the takeoff weight of the aircraft. We're gonna use also calculations about the flap settings for takeoff. I'm gonna show you how to use the flaps and the horizontal trim stabilizer. This is gonna calculate the mean aerodynamic chord position and the center of gravity in terms of the mean aerodynamic chord of the forward wings of the aircraft, the Mach percentage. So you will see also these calculations that will determine also the horizontal trim stabilizer for takeoff, and the V speeds, the V1, V rotate and V2 for takeoff. I'm gonna show you also how to use all this data to input the takeoff data, like we're gonna select the departure airport and runway. We're gonna use the runway conditions, if the runway is ice, wet or dry, the distance, the length of the runway and the runway slope, the wind direction and speed, the barometric pressure and the density of the air, and also the temperature of the air. Other data, like also we're gonna use, I told you about the takeoff weight of the aircraft and the flap settings for the trim stabilizer. So we're gonna have also the seats, the SADR instrument departures for takeoff, the climb and the cruise, the descent and the approach. We're gonna have intermediate waypoints and fixes, and we're gonna have also the destination airport and runway. We're gonna use the stars, the standard terminal arrival, waypoints and fixes, and also the ILS localizer, frequency of the destination, runway and airport. We're gonna select for the horizontal localizer and the vertical glide slope. It's gonna guide. You're gonna see in the primary flight display over here, display the ILS localizer when we go mainly full landing. So you're gonna see after that. I'm gonna show you also the autopilot and flight director. So we're gonna have a complete flight plan or flight path or route for the vertical and horizontal navigation of the aircraft, either manually or automatically. This is gonna also engage the thrust commands using the auto throttle. We're gonna follow it manually. So I'm gonna show you also the autopilot and flight director system panel. I will show you the autopilot engage and disengage switch. Also the auto throttle left and auto throttle right engage and disengage switch. The flight director engage and disengage switch. You can see here. I'm gonna show you also the airspeed select node. We're gonna select an airspeed in nautical miles per hour knots or Mach speed, and we're gonna select the modes for that. Two main modes. We have the fixed thrust mode and the variable thrust mode. So we're gonna use the flight level change, the climb continues or the auto throttle with the speed, and this is gonna engage a thrust command from the autopilot and flight director to the engines of FADEX. The FADEX are the Flow Authority's electronic control computer, one installed per engine. I will explain you later. So we're gonna have two main modes, like when we are in takeoff, in climb, or in descent. We have the fixed thrust, like maximum continuous climb thrust, or takeoff ground thrust, or idle thrust for descent. In either case, the airspeed of the aircraft is being adjusted by varying how fast the aircraft climbs or descends. That is the steepness of the angle the aircraft climbs or descends. Also, we have the fixed thrust mode, in which during the cruise phase of the aircraft, in the horizontal flight path or in approach and landing, we have the aircraft altitude is stable in flight. So we have the variable thrust mode, in which the airspeed is being adjusted by varying the thrust commanded by the engine's FADEX. So the FADEX are the Flow Authority's electronic control computer, one installed per engine, gearbox, one in the left wing. We have one engine in the left wing, one in the right wing for this aircraft, the Boeing 777-300ER. The General Electric 90G90 turbofan engines. So this is a jet aircraft, so I'm going to show you also that. We have also the LNAV and the VNAV, the lateral navigation, the vertical navigation here, which is interconnected to the flight management computer. So all the inputs of the flight management computer will guide the LNAV and the VNAV, the lateral navigation, vertical navigation. We also have the bank angle limit hold switch for the aircraft cruise flight. We have the heading select knob, the heading hold switch. We have the vertical rate of climb descent in tens, hundreds, 1,000 feet per minute, or a trigonometric angle in degrees, the DFP mode or the VS mode. We have also the altitude and the hold switch for this mode, and the slider, so you can adjust how fast the aircraft will climb or descend over here with this slider. So this is the airspeed, the heading, the vertical rate of climb descent, and the altitude select knob. You can see here. So either one mode I will explain you after that. So we also have the altitude select knob and the altitude hold switch. We have the world localizer for the Lszh localizer approach, and the approach switch for the auto land function of the Boeing 777-300ER. Then I'm gonna show you the thrust levers, how you can use the thrust lever position in conjunction with the auto throttle system. Either one, you can disconnect also the auto throttle while try to fly manually the thrust lever. Command the thrust and adjust the airspeed this way and the altitude of the aircraft in flight. So you will see over here the thrust levers, how we can advance, forward, or aft, what they can do, other things that interact with the thrust levers. You can see some instruments, and also you can see the upper and the lower ACAS and the indication control system display, which displays all the data from the FADEX about the engines, like the N1, the exhaust gas temperature, the bleeder pressure, and the N2, which is the high-speed starter and shaft, the high-pressure compressor turbine, the fuel flow principle, pressure, temperature, quality, and the vibration of the engine. So I'm gonna show you then the flight controls. I will show you how you can control the aircraft elevator, horizontal tail elevator, climb and descent using the control column, and the other ones and the spoilers for band rolls left and band roll right. You can see here. So you can see here I have I have this to control the flight controls of the aircraft, to control the yoke, so you can climb and descend and bank roll left and bank roll right. Also use the rudder pedals left and right. So I will show you now. After that I will show you the overhead panel. I will show you the electrical, the hydraulics systems. So I'm gonna show you how to start the engines. We're gonna start the APU, the auxiliary power unit. I'm gonna show you the ADIRU, the primary flight control computer, the left and the right engine driver, and the backup generators for the electric power. So this is the electrical panel. I'm gonna show you the hydraulic panel, the rammer turbine, the passenger oxygen, the electronic engine control for the engines, the fire extinguishers, the fuel jettison. You get dump some fuel in flight, and the fuel tanks, the left wing, right wing, center tank, and the fuel booster pumps and the crossfeed valves. You can balance the fuel between the left and the right wing, or use one wing tank to feed both engines. So we have also the cabin pressurization and the bleeder from the left and right engine, and also from the APU unit bleeder to start the engines in the ground. So I'm gonna show you how to do all these things. We also need cabin pressurization, wing and engine anti-ice over here, hydraulic fluid pressurization, air conditioning and ventilation, and start the engines using the APU, the auxiliary power unit. So this will provide for hydraulic power in the ground. So I'm gonna show you now how to use the flight controls here, the control calling the control wheel. So I will show you how to control the flight controls of the aircraft. I'm using this size stick, the Logitech Extreme 3D, for controlling the flight controls of Boeing in this simulation. So you can see I can use this side stick. I can climb the aircraft in flight. So I can climb, I can descend. I have other size. You can see the side stick deflection is proportional to the flight controls, the yoke, the control. So I'm going to show you also. So you can see the side stick deflection is proportional to the yoke. So I have full control of the aircraft. Also we can use the thrust levers here to increase the thrust, and also decrease the thrust. We can use all instruments simultaneously, increase and decrease the thrust, make turns left, make turns right, and also the rudder pedals left and right, the vertical stabilizer. So this is the horizontal tail, up and down, climb and descend with the horizontal tail, the elevator. This is the ailerons and the spoilers, the control wheel, left and right, bangle left and bangle right, and this is the rudder, the vertical tail stabilizer, rudder pedals. So you can see both sides are interconnected to move simultaneously like that. And we have also the horizontal trim stabilizer. I will show you here. We have the horizontal trim of the horizontal tail stabilizer. Here you can trim the horizontal tail up and down, and see where the horizontal tail trim position is. Here you need that to balance the aircraft in flight. You can use also these trim tabs. I will show you now. After that, also the rudder trim and the aileron trim here. So this is how you control the aircraft using the flight controls. I will show you also the outside view, doing the same thing about the flight control functions. So you can see here we have the outside view. You can extend the spoilers. You can see the horizontal tail with the horizontal trim and the elevator, the rudder and the ailerons and the spoilers over here, and the flaps are extended. So I will show you now how to use the side stick for this function over here. So you can climb and descend. So this is how climb, descend, use the elevator, also the rudder, left and right, and the ailerons, bang roll, left and bang roll right. So it takes like a couple of seconds for most of the flight controls to react like this. So you can see how we control the aircraft in flight like this. So I will show you now inside. I will show you the other instruments, then I will make an engine start demonstration. So thank you very much again for joining me in this video. I'm Thomas Hatsios, a German-American pilot flying the Boeing 777-300ER. I'm gonna start now. So we have everything in the cockpit set. You can still see outside view over here. So I will talk to you also about other things. So we have the primary flight display. You can see here is the airspeed tape, the airspeed indicated, 30 knots, the ground speed 0, the airspeed selected from the autopilot and flight director system panel 200. Notes over here, you can see all the values, 200, 360, 0 and 10,000 feet right now. You can set also meters and inches of mercury or hectopascal. So we have inches of mercury 39.92. The altitude in feet and meters also displayed. So we have also the barometric altitude above the sea level. The target altitude selected from the autopilot flight director system panel, the vertical rate of climb descent with the aircraft in 10,000 feet per minute. Also you have all, here is the magnetic heading and track, the magnetic north pole, the true north pole. Now we have the geographic north pole for navigation, so you can switch using this small switch either one, geographic or magnetic north pole. So now we have the magnetic, we have 39.92 inches of mercury, we have the vertical rate of climb descent of the aircraft, this state, tens, hundreds and thousands feet per minute. You have to pay attention. This is the pitch ladder, the altitude indicator, the pitch ladder in decrease, 2.5, 5, 7.5, 10, 12.5, 15, 7.5, 30 degrees. So this is the pitch altitude and also the climb. You can see the climb here. If the aircraft climbs or descends, you have to follow this needle. Rather, this is the pitch altitude. So you might have a positive pitch altitude like 5 degrees, but the aircraft might descend in flight, having a vertical flight path. I'm gonna show you also, this is the navigation display. You will see the radar scan here. You can see some aircraft flying closer or farther away from us. So we might have a couple of aircraft now, like 10 nautical miles away. You can see one aircraft here is blinking and it's coming closer and closer. So monitor that. You can see the diamond shape here. There is another one. So this is plus 2,700 feet, this is plus 9,900. You can see the position of the aircraft here. So this is using this system here, the transporter, the being ADC transmitter receiver. You can test that. You have also the weather radar here for the terrain reflections. So you can see the traffic now displayed in the warnings. Some other aircraft. So let's do that again. Just one more time. We will see what happens. So we have the traffic. So we have the pitch ladder decrease, the bank angle decrease with the angle of attack of the aircraft has this license, flight mode and on-schedule, the autopilot and the autofollow, later on vertical navigation modes. So we can set here autothrottle left off. You will see autothrottle left off, auto throttle right off, both off, one the right off. You will see the auto throttle right display with yellow warning over here. Both on. Flight level change, here you can change the mode, turn off the flight director like this. It will disconnect and also reset the mode. So we'll set an airspeed for flying the aircraft after takeoff, indicated airspeed Mach, and you can see all these switches are functioning. So you can turn off the mode. So we have an aircraft coming in right now. We will monitor and see. It's plus 1,100 feet. Is descending. You can see the diamond shape and the arrow down means the aircraft descends 1,000 feet above our elevation. Is about 3.5-4 nautical miles away from us. Plus 900 feet. Is coming closer to our position, so this is the distance between us and the aircraft. You can see the aircraft in front of you over here with the red beacon. Is coming closer, so we have it here in the display. Plus 600 feet. It's almost 2.5 nautical miles, closer and closer. You can see the diamond again. Plus 500, plus 400, it's getting closer and closer. This is what we need to pay attention. Plus 300, and we have the traffic here, the display. So this is in front of you and generates the traffic warning from the takeoff system. So you can see the aircraft coming for landing. It's flying very close to us, so we still have it here in the navigation display. It's coming close by to us and the traffic warning. So that was all for the traffic. Now we can see more aircraft flying around us farther away. So we'll set a couple of things here in the autopilot. Director system panel. We have heading and track, the bank angle of the aircraft as it flies. So I'm gonna set the heading here. We're flying the aircraft. We're gonna set the runway for takeoff. Select and deselect this. The altitude also. So we're gonna set 35,300, and now we have the airspeed and the heading. So this is the target airspeed after takeoff and the target altitude for this heading, holding flight level change speed with the flight director on, not the autopilot. So this is manual. If we set the autopilot, we're gonna have the autopilot on like this over here. With the green light, we can set off with this. You will see the warning coming in. So we set the autopilot now on. You will see the AP here on with the flight level change speed and the heading hold. So we take out the autopilot like this. You will see the warning, and the autopilot is disconnected with the red letter here. So we reset again one more time. So now we can use also the other mode, the altitude hold over here, or heading, or flight level change speed. So we have the altitude with the heading hold and the autopilot. Also we have a couple more modes. We have the approach and the other flight director. Also we can use all these flight path angle like this. like a descent, like -3.5 degrees, you will see the slider moving. You will set -3.5 degrees descent rate for the aircraft to vertical flight or descend or climb. So you're gonna have here a minus below the horizon line here. In the altitude indicator, you can see these two purple lines between the -2.5 and the 5. So this is -3.5 degrees over here. With this mode, the FPA here and the heading hold. So this is gonna be also, we're gonna use the positive value for that. So we're gonna have like a climb. So it's gonna be like plus. So plus signals a climb over here. As you can see, you move the slider like this. So we're gonna have the climb here plus 3.5 degrees. So it's gonna be over here displayed. So this is gonna be the pitch altitude for the aircraft in flight to attain this airspeed and this altitude target altitude with this mode, heading hold and type angle with the autopilot on from this altitude, this elevation. So you're gonna see the needle moving up. When we climb, also we can use the other mode, the vertical speed. So you can set like -3,500. With -3,500 feet descent over here, heading hold vertical speed, and you have the descent rate here with the purple indication, this purple arrow. This when it descends from the cruise altitude. So we're gonna make it the opposite way now. We're gonna have a climb like plus 3,500 feet like this. So this is gonna signal a climb rate now with the vertical speed here and the heading hold. So we're gonna have to climb to this target altitude with this target airspeed, and this is gonna be the vertical rate of climb over here, this purple line. So you have to know these things about every detail about your aircraft, how you use it. So we can disconnect again the autopilot. You will see autopilot disconnect. We have flight director now, and autopilot disconnect here with the red letter reset, and we can disconnect the autopilot now. I'm gonna use this small switch in the control wheel, or we can move the control wheel. So we will move this switch. We press this switch, we have autopilot disconnect, just like before, with the warning here in the upper ACAS. Autopilot disconnected. You can hear the oral warning. So we press one more time, and this confirms the disconnect action to cancel the warning. So we take full control now of the aircraft. After that, we're gonna use it for takeoff and flight and coming back to the airport. So I'm gonna show you now the upper and the lower ACAS, the thrust levers. So I told you we have the horizontal trim stabilizer here with pitch trim, the horizontal tail of the aircraft. Over here you can see the horizontal tail, and the vertical tail also has the pitch trim and the ailerons and the spoilers. You can see the aileron trim here, the position, how many degrees. So you have the elevator trim, and also the rudder trim with the aileron trim here. So you set the horizontal trim position, pitch trim up and pitch trim down. The horizontal tail, you can use the pitch trim, the normal and the alternate tabs. You can use see where the horizontal trim position is. The green band is for flying and for takeoff, and we have it 4.25 degrees. Also, besides having the manual trim order, this is the manual trim of the horizontal tail. Over here, as I told you, horizontal tail that would trim up and down. We have the autopilot and the auto throttle. Also use the pitch trim. So if you lose the C or the R, the hydraulic system, if we have a failure, we can have a failure of the auto trim function of the autopilot and the auto throttle. So we have this switch, this guarded switch here. We disconnect the auto trim from the autopilot and the auto throttle like this. If you lose the C or the R or both from the normal to cut out, as you can see over here. So we use this also. So after that you can have only the manual trim of the horizontal trim stabilizer. We have also here other things. You can see the parking brakes up and down. So this is for the manual trim and the auto trim function. We have the thrust levers up and down. You can see we have the speed brakes extended and move the thrust levers forward. The speed brakes retract automatically. You can see the speed brakes here. So you can extend the speed brakes also when the thrust levers are idle. You have also other things over here. You can see the flaps position. You can retract the flaps fully or extend them fully. Use them accordingly in flight, according to the airspeed and the altitude of the aircraft. So you have the flaps position here, now it's fully extended. You have also the landing gear, up and down, extend and retract here. The alternate gear, the lock override here. Some things not related to the engine, some other guarded switches. So you see the landing gear extend and retract. You can see also the auto brake. You can see the extend and retract speeds for the landing gear. Also the auto brake, how to use it if you need. Reject the takeoff for landing. Flaps limit, the airspeed for the flaps, extend and retract the Boeing 777, the mark of the aircraft. Some other things I will show you. We have also, as I told you, the thrust levers. You can see we have the fire extinguisher for the left and the right engine. You pull out this and twist. We have the fuel control, the fuel flow to the left and the right engine. These switches. The OVC panel I will show you in a couple of seconds. So you see the thrust levers. We have also the speed brakes, and we have the auto throttle, the disconnect switch. You press one time and you disconnect the auto thrust. We have the takeoff go round switch here. We have the thrust reverse. You press the thrust reverse like this, and you extend also the speed brakes automatically. You can see the N1 here, the reverser, N1. So this is the reverse thrust here. So you can also retract the thrust reverse like this. You retract in the speed brake. You can extend again. You can see the locker doors are open and they reverse the flow of the bypass of the engine. So you retract again the thrust reverse, extend again and retract. So this is all for the engine's function right now. For the thrust reverse, I will show you the upper and the lower ACAS now, the displays of the engine. So we can move one engine at a time. Also, we have a failure, you can see. Also this retract. So you can see the N1 here, you can see 44-46% for the right engine, while the other one is at idle. Move both together. This is how well this is simulated. The variable thrust. If we have an engine failure, we use only one engine. So you can see N1 at the left engine now, idle the other one, the right engine. So this is also the radio and communication panel. I forgot to mention the flight management computer. So you will see a lot of stuff. We have the thrust levers forward. You will see, I'll show you how to use it. You can see the N1 increases. You can see the position, the thrust lever position, the actual thrust. Now we have it at idle. It takes some seconds for the thrust to increase from the actual to the commanded position. So you have to anticipate that when flying the aircraft, the airplane. So you can see 104.6% for maximum continuous takeoff thrust. So this is the N1. The N1 is the low speed starter and starts a low pressure compressor and turbine of the turbofan turbocharged engine with the green, red and yellow limits. Takeoff, ground, exhaust gas temperature per engine, other things not related to the engines, like the total fuel on board and the temperature of the fuel. The bleed air from the 5th and 9th engine, which 5th and 9th stage of the engine, which feeds also the cabin pressurization, the rate of the flight of the cabin in flight for the cabin pressurization system, the hydraulic fluid also, and other things like the air conditioning regulation. We have also the N2, the high speed starter and start the high pressure compressor turbine of the turbofan turbocharged engine, the fuel flow per engine per hour, thousands of kilograms or thousands of pounds, oil pressure, oil temperature, oil quality, and the vibration of the N2 stage of the engine. So you can see when I move the thrust levers forward and off, so this commands. So we have this aircraft, the Boeing 777-300ER jet aircraft. So we have jet engines installed. General Electric 92 turbofan engines, one in the left wing, one on the right wing for symmetrical thrust and redundancy. They provide the forward propulsion. So we have the H engine also contains a gearbox with the IDG, the great drive generator for electric power. I will show you later. Also the hydraulic pressure and also the cabin pressurization, the bleed air pressurizer. Also the gearbox contains the FADECs. The FADECs are the fuel authorities, they are electronic control computers, one installed per engine, load channel redundancy, one channel fails. The other takes over, controls, monitors, displays all the data you see about the engines, about the left and right engine of the aircraft. Like the N1, which is a low speed starter and start the low pressure compressor and turbine of the turbofan turbocharged engine, the exhaust gas temperature per engine, the bleed air pressurizer from the 5th and the 9th stage fan blades of the engine. Also the N2, which is the high speed, the N2, which is the high speed starter and start the high pressure compressor and turbine of the turbofan turbocharged engine, the fuel flow per engine per hour in thousands of kilograms or in thousands of pounds. The oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. So we have also the FADECs controls the overpressure inside the engine. We have an overpressure that can open the outflow valves into a higher setting to release the pressure from inside the engine. We have an underpressure that can close it to increase the pressure inside the engine. Also, as we climb the aircraft from the sea level all the way up to the cruise level, like 20, 30 or 40,000 feet above the sea level, as we climb, the temperature of the air becomes freezing, like minus 30, minus 40, minus 50 degrees below Celsius. Also the oxygen level of the air and the air density and the pressure of the air becomes less than half of that of the sea level. Also the aircraft flies with an airspeed rate like 2-3 times faster than that of the sea level, so we have higher fuel mixture request every second, a different fuel mixture. Also, as we vice versa descend from the cruise level from 30 or 40,000 feet back to the sea level. So this fuel mixture and also the intake of the air from the front fan stage into the engine needs to be regulated from the FADECs. So this is done automatically. It's a good thing to have the FADECs installed into your engines. Now we'll talk about the newtons per second, third law of kinematics of motion, about the Bernoulli theory of fluids. about aeronautical and aerospace engineering and derive some interesting principles you need to know for flying the aircraft about the pilot license. Also use the outside view. Then I will make the engine start demonstration and make a complete flight from takeoff, cruise, climb, descent, and approach. So I will show you all the places of flight. So you can see here we have the aircraft. You can see the aircraft wings hold the weight of the aircraft as the aircraft flies. You have also the mean aerodynamic chord position, about 25% of the Mach. It's the position where the maximum aerodynamic lift occurs, also where the center of pressure above the wings occurs, and the stall, the airflow becomes detached from the top of the wings, so the aircraft wings stall. About here we have also the center of gravity of the aircraft that transverses here the longitudinal axis and the lateral axis of the aircraft. We have the vectors from the engines, the propulsion, the thrust that overcomes the kinetic and static friction. So the thrust from the engines move the aircraft forward, and the lift from the wings overcomes the weight of the Earth's acceleration depending where we are in the world. We have also the distance from the center of gravity all the way back to the horizontal or vertical tail, over the surface area of the horizontal or vertical tail, over the airflow of the air mass per second. And we have the lever arm. You can see the lever arm is the force that climbs or descends the aircraft, also makes the aircraft turn. So also we have the wings of the aircraft. You can see the bottom surface of the wings is more flat. As the aircraft flies, there is using the Bernoulli theory of fluids, the airspeed of the air moves slower below the wings, so we have higher pressure below the wings, which pressurizes the aircraft up into the air. Also the top surface of the aircraft is having higher curvature, so the airflow of the air mass moving much faster using Bernoulli theory again. So this sucks the aircraft wings up into the air. So this is a few interesting things you need to know about physics. So also I will show you how to make an engine start demonstration. I will show you the overhead panel now. So we have these switches to disconnect the hydraulics for maintenance in the ground. We have the circuit breakers here to reset in flight if we need something to reset. You can see also the view of the cockpit here. So we're gonna set for takeoff the flaps. So we have the data necessary reference unit, the thrust symmetry compensator on and off. The APU, we need to start, this is the electrical system, the left engine, the right engine, IDG, the great drive generator, 120 to 100 volts, 400 Hz frequency, 100,000 kilovolts, also the APU, and the backup generators, 25,000, the battery, 28 volts for the upper hour. We have the passenger oxygen, the ground proximity, the fire extinguishers, the rammer turbine. This is the hydraulics. So we're gonna turn off all the hydraulics off. You will see what happens. So this is the layout of the overhead, also the fuel system and the bleeder. So you're gonna see all the faults coming up, all the hydraulics over here. So we're gonna have alternate flaps like this, and also the stabilizer is lost, the flight controls hydraulic pressure system, C, L, C, and R. You can see all the hydraulics and autoland flaps. So this is all the stabilizers. This is all the flight controls we lose for the hydraulics. So about to on and then to auto. So we have the electronic engine control for the engine. I'm gonna show you normal and alternate mode. Auto start here. You can use the auto start on and off like this. This is the fuel jettison. You can dump some fuel in flight to lose weight. Also arm the nozzle, select how much fuel to remain. The crossfeed valves, the fuel booster pumps, left wing and the right wing tank, and the center tank. So this is the fuel on board. The center tank is empty. wing and engine RPI is also here on. You can see also this is the lighting system and the windshield wipers. So electrical, hydraulic, electronic engine control for the engine, fuel system, fire extinguishers, cabin pressurization here. So this is normal and automatic and manual. You use the outflow valves, open and close, and select the landing altitude for the cabin pressurization manual mode. We have also the bleeder. We need the bleeder from the APU to start the engines, so I'll turn off the bleeder, the pressurizer from the engines and from the APU. The APU is a small auxiliary power unit. The tail, you're gonna seal the bleeder, also the pressurizer, the cabin pressurization is closed, and we're gonna lose also some hydraulics now. Hydraulic pressure demand here, C1 and C2. So we need to reset again all this, the APU. So this is all you need to know about the overhead panel. Now we'll show you CDU. So this is the last thing before starting the engines. You can see the displays of the system. We have also the flight management computer. So we have the engines, the starters. You can see the APUs running, the hydraulic and the oxygen level, the checklist, the normal menu, the reset here, and the non-normal if we have a failure. Some system communication, navigation, synoptics, the doors are closed and the cabin can be pressurized. The landing gear, you can see the temperature of the brakes and the pressure of the tires. The electric system, left engine, right engine, backup generator, the APU also running, the main battery, volts and the discharge, and also the APU battery, the hydraulic fluid, left engine, right engine, electrical, C1, C2, 3000 psi each system, the quality of hydraulics, also the shut-off valves, and where hydraulic fluid goes with system use it. The fuel on board, you can see the left wing and right wing tank, the center tank is empty, how much fuel you have, total fuel and its tank, left wing, right wing. You can see the low and high pressure fuel valve, this line of the left and right engine. The crossfeed valves can balance either left and right wing tank. Also you can feed either engine from either tank or pump. If you lose a pump, forward and aft fuel booster pumps, and the APU is fed from the DC motor using the left wing tank here. So we have also the minimum fuel temperature if where the fuel freezes, the left and the right engine. The APU, we need the backflow. This is the air pressure from the engine and from the APU. We need the APU to start the engine. We increase also the engine thrust. You will see more pressure. And the last one is the flight controls. We can see here we have all the flight controls modes here. Everything is working normally, and here so you can see all the flight controls are normally working, movement, full movement, and also the ailerons, the elevator, the tail, and also the trim. So we need to turn off the engines. Both engines are gonna be off like this, and we're gonna restart both engines. So we turn off the fuel flow. We're gonna have some reset in the overhead panel, also electric reset. So we have engine start down, engine auto start, left and engine auto start. You can see here auto start and engine start on. So you can see no fuel flow here. We have the engine spinning because there is the pressurizer from the APU. We have the auto start on, so we only need the start the fuel flow valves here to the run. So we're gonna have the engine start now. The fuel flow increases, and we have both the right and the left wings. You can see the engine, the fuel flow in the N2, and we are ready for almost ready for takeoff. We need only One last step, the flight management computer here. So we need to set the flight management computer, initialize, menu. We have the FMC position, this reference airport Lszh. So we have 0 fuel weight, reserves 5%, cruising altitude 35,300 feet, and the cost index 100%. Over here, minimum cruise temperature, and also the departure Lszh, route 1, request, and runway, departure, arrival. So we have the departures, 02 Alpha, and arrival Lszh. So this is the flight management computer. We create a flight plan or a route or a flight path for the aircraft, activate and execute. We have the flaps for takeoff, the center of gravity, and the takeoff speeds, V1, we rotate, and V2 with this takeoff weight, and we have all the everything is set. So we cancel the parking brakes, advance the thrust levers, and it to taxi. We have taken already the request for taxi and for takeoff from the air traffic controller here. So we have taken the clearance for takeoff, and the runway is open. So we need to align here with the runway. So parking brakes again, everything is set, the LNAV on, a new range, you can see the radar scan again, the flight plan, flap set, the frame also we use maximum takeoff thrust over here. So you can see where we are and where we're going right now. So we're gonna have a nicer view for takeoff. Over here, parking brakes are released and go. Realign with the rudder pedals also. So we have 100 V1, we rotate. So let's rotate. And the V2. So here we go. Be careful not to hit the runway. So we have the positive rate of climb, landing gear up. So we have, you can see we are about 2,200 feet, 2,500 above the sea level, above the ground level, 4,700 above the sea level. The airspeed is 210 nautical miles per hour. We climb with 7,700 feet per minute. You can see also the stall speed. You can see the flight plan we have to follow. So we need to level off to increase the airspeed of the aircraft, and also start the turn. so you can follow here what's going on. See the flight plan, the airspeed, the stall speed is here, the flap limit, the rate of climb, the bank angle, and the waypoints. We have the flight plan from takeoff here, and we have to follow this. Find some other traffic, the engines here, and the autopilot setting. So we need also, I will show you an outside view now of the aircraft. So we have about 16 more minutes left for this video to end for the flight. So I hope you like it. So the star sign over here, hope you like it. A beautiful star sign and this beautiful view of the Switzerland. So this is a Boeing 777 300ER. Hope you like the view on the aircraft. We fly with about 600 kilometers an hour. So we're gonna have also another turn now as we climb. Nice minute to use this. So we keep flying and on next waypoint. We need also the next waypoint. So this is gonna give us the first waypoint over here. You can see the flight plan. You can see also here we have to follow it. It's like 1.3 nautical miles, 1.2, 1.1. Over here you can see also again the airspeed, the altitude. 0.6. We're very close. Then we have to follow the next one after you can see again the stall speed. So this is all the configuration right now as we're flying, and we have about 30 more minutes left for this flight. So you can see all the indications here. So you can see we have the Germany in front of us with the Bayern Munich, we have the France on this side, and the Switzerland here on this side. So we are 21, keep increasing to track the flag. 32,000. We almost reached 33, 34,000. Here we are. We have the chemtrails and the contrails, the frozen vapors. So this is our spacecraft for tonight, the Boeing 777-300PR, and you can see all these beautiful chemtrails. We are getting 3,300 feet, and we're flying with almost 600 kilometers an hour. I hope you like also the galaxy, the view of the galaxy here. Also we have the Switzerland here, the lakes here of the Switzerland, it's Galen. We have the Germany in front of us, the Bayern Munich, and the France on this side. So this is the chemtrails. Hope you like the frozen vapors. So we need to start going back, flying to the airport. We haven't reached yet the cruise altitude, but we're gonna start making the turn, manual turn. We are very close. Also the waypoint, you can see 8.3 nautical miles away, and we need to increase the airspeed like this. So we reach the cruise altitude here. We need to retract also the flaps. So you can watch as we are trying to balance the aircraft here manually. We're flying manually 35,300 feet. Also we have maximum continuous flaps. So we turn over here, leave behind the France, and we turn over. We have the German in this side, the Bayern Munich. Very close to the Germany, like maybe 15 minutes of flight for the Bayern region. So we fly now with 980 kilometers an hour, or about 'So you have the Germany, the France, and the Switzerland, beautiful views, and the galaxy, and the frozen vapors here. 980 kilometers an hour, or 300 meters per second. Our aircraft, Boeing 777 right now. So we have to go back to the airport. We have a few more minutes left. We can also connect the autopilot like this. So we have to display the autopilot navigation, and we have like 8 more minutes left for this flight. So now we are flying with the autopilot. Over here. Maybe we're gonna use less waypoints over here. And we're gonna have also the landing, the airspeed select for landing, and the flaps. So we're gonna have to set the aircraft now for descent in a couple of seconds. We need to select so this is flying 35,000 feet, 35,300 feet, and we need to reset the airspeed. Also the altitude. And the vertical speed. So we're gonna have this speed brake extent, and we're gonna have 34,300, and we keep descending over here. 980 kilometers per hour, 300 meters per second. And we have 6 more minutes left for this video to end. 31,000. You can see the airspeed. We have manual, automatic speeding thrust. Vertical speed, the waypoints over here. So we don't fix that. $16,000, and we have the landing gear down. Press the flaps and disarm the autopilot like this. So we take the control now. And we need to start the descent. 4 more minutes. For the flight to finish. Decrease the airspeed also more. For the approach and landing. So we're gonna be less than that. And we have 3 more minutes, I believe, left for approach and landing here. So we can see where we are as we approach. So we are aligned now with the runway, and we have 3 more minutes, I believe, for the video to end. We need to align with the rudder pedals like this, and with the cross flight controls. We have to turn a little bit to the left, and it should get lower a little bit. So you can see the ILS localizer where we are right now. All the information, we are 1,400 feet above the runway. We need to make a turn to the right to align. Also the glide slope, we are inside the glide slope, and we have 1 minute to go for this flight sprint. So we need to align like this with the runway setting. So here we are. $200, 100, 30, 10. Here we are, just touchdown, parking brakes and reverse, full reverse thrust. So we have the parking brakes and the full reverse. So we just touched down very nice, and you can see a very beautiful landing. You can see the nozzle here is perfectly safe. Also the landing gear here, everything, all the parts are normal of the wheel. So the aircraft is standing up the way it should be. The nozzle and the landing gear over here, as you can see. Also